Hello, hi everyone. Welcome to the Stone the Brand. This is your sir. Today we are going to discuss about the amazing topic, wonderful topic, extraordinary topic, marvelous topic. So very interesting topic, that is work and energy and power. Work, energy and power. Okay. So we'll discuss about this topic. So, generally, every day when you wake up, so you do so many works, okay? Carrying, so if you go to shop and carrying the things, so going to the market and bringing the vegetables, going to the shops like grocery shops and bringing the groceries, like that. So we do so many works, right? So what exactly the work? Work is nothing but when we apply force on the object moves from one place to another place. Okay, like that. So when we apply force on the object moves from one place to another place. That is called work. So here there are three types of work: work, energy, and power. Work, energy, and power. Okay, so work, energy, and power. Here in this topic, so we'll discuss about work done. There are three types of work done: positive work, negative work, and zero work. Sir, we know that when we apply force on the object, so when you apply force on the table moves from one place to another place. Then we can say work is done, right? So when you are drawing the table, pushing the table, okay, opening the door, closing the door, applying force on the door, like that. So we do so many works, right? Every day in our daily life. When we apply force on the object displaces. Then we can say work is done, right? So in the work, there are three types are there. One is positive work, negative work, and zero work. Sir, what is positive work? What is positive work? So here you can see, here you can observe. So I am taking the surface. This is surface. So like we can take ground. So this is the object. I'm applying force like this. This is the F. Force is applying on the object. Okay, the object is moving along the horizontal direction. Along the horizontal direction. When we apply force on the object moves horizontal. Okay, that's the example table. So when you are drawing the table, we will apply some inclination. Okay, so with the horizontal surface, but object moves horizontally only on the ground. Yes or no? So chair, table, and luggage bag, all these examples we can say, right? When we apply force on the object moving horizontally. So the angle between force and displacement is theta. Force and displacement is theta. So that is the angle between them, right? Okay. Now you can see W equal to F bar dot S bar. So force and displacement are both are vector quantities. Sir, what is vector and what is scalar? The scalar, coming to scalar is nothing but the quantity which has only magnitude, that is called the physical quantity which has only magnitude, that is called a scalar physical quantity, and the physical quantity which has both magnitude and direction. If you say vector scalar, the physical quantity which has only magnitude, best example mass, speed, density, like these examples we can say. Okay, so speed 2 meter per second, 3 meter per second, density 4 kg per meter cube, like that, right? So density is nothing but mass per unit volume. Mass per unit volume. And coming to the mass is also scalar quantity. 2 kg, 3 kg, 4 kg. And the distance. 2 meter, 4 meter. So the physical quantity which has only magnitude, then we can say it is called a scalar quantity. Scalar physical quantity. Sir, what is physical quantity? So the quantity which can be measurable. The quantity which can be measurable is called physical quantity. Okay, here there are two types of physical quantities: scalar physical quantity and vector physical quantity. Scalar means the physical quantity which has only magnitude. Vector physical quantity means the physical quantity which has both magnitude and direction. Simply we can say scalar quantity and vector quantity. Scalar quantity and vector quantity. Understood or not? So here coming to scalar. So example, displacement, velocity, acceleration, force. These are examples for vector physical quantity. Simply we can say vector quantity. Understood or not? Yes. So now you can observe scalar and vector. I hope it is very clear. Now when we apply force on the object with the inclination, so the angle between force and displacement is theta. The dot product of two vectors is a scalar quantity. Okay, actually, so dot product of two vectors will get scalar physical quantity. Okay, so it is a scalar product. Scalar product. Understood or not? So now you can take W equal to Fs cos theta. Fs cos theta, because the body is moving along horizontal direction. Along the horizontal component is responsible for the movement of the body. That's why we are taking cos theta. That's why we are taking cos theta. Understood or not? Right? So object is moving along horizontal direction. So W equal to F bar dot S bar. Sir, why we are taking F bar dot S bar? So F bar and S bar are both are scalar physical scalar vector quantities. Both are vector quantities. That's why we am taking F bar dot S bar. Okay, so W equal to Fs cos theta. Fs cos theta. If you are removing the dot product, we'll get cos theta. So y cos theta along the resolvation of the component, resolving the components. So if you are taking here along x-axis, force component we are resolving along the horizontal direction, that is f cos theta into s. So Fs cos theta we are taking. So resolving the components we consider. So along x-axis and y-axis, this is x-axis and y-axis, this is a force. So F bar I am taking. So this the angle is theta. Suppose if you take angle is theta. So it is a right angle triangle like this. This is F theta and this is the x-axis and y-axis. Coming to the cos theta. Cos theta formula is, so adjacent side by hypotenuse. So adjacent side is F and S. So that is x equal to F cos theta. And coming to the sin theta formula is sin theta equal to opposite side by hypotenuse, that is y equal to f sin theta. F sin theta. So here which component of force is responsible for the movement of the body? So here the body is moving along horizontal direction. Even though we are applying force with some inclination to the displacement, but still the body is moving along horizontal direction. So here if you resolve the components, if you resolve the force into two components, so along x-axis and y-axis, so along x-axis, what is that one? F cos theta. So the force component along x-axis, F cos theta. So this is responsible for the movement of the body. Okay, so body is moving along horizontal direction because of F cos theta, force component. Because of the force component, the body is moving along a horizontal direction. Okay. So that's why it is moving along a horizontal direction. That is F cos theta. F cos theta. Understood or not? That's why we are taking Fs cos theta. That's why we are taking Fs cos theta. After removing the dot product, we will take W equal to Fs cos theta. After removing that, Fs cos theta. I hope it is very clear. Understood or not? Now, so this is very important. Resolving the components is very important. Along x-axis and y-axis. So x-axis direction component is x equal to fx cos theta, and along y-axis y equal to f sin theta. Along y-axis F sin theta. Along x-axis, F cos theta. But why we are taking only F cos theta? So why you are taking only F cos theta? Why you are not taking F sin theta? So body is not moving vertical direction. Body is not moving upward direction, right? Body is moving horizontal direction. Even though we are applying force on the object with some inclination, but body is moving horizontally. Okay, that's why we are taking F cos theta. F cos theta. Is it clear? So, which component of force is responsible for the movement of the body? So, that force we are taking, that along the x-axis. So, along the x-axis, which component is acting? F cos theta. That's why we are taking W equal to F cos theta. So, the overall formula is work done on the body, that is equal to Fs cos theta. Fs cos theta. So with the help of this one, we will discuss about three types of forces. Positive, so three types of work done. Positive work done, negative work done, zero work done. So how it will be? So when we apply force on the object, so suppose I am taking this the body, this the body. When we apply force on the object, so here I am taking this the force. So the displacement also will be in the same direction. Force and displacement acting in the same direction. So if you are taking, when we apply force, force is here, and displacement also will be in the same direction. Okay, force and displacement are in both same direction. Then we can say work done is positive. Work done is positive. Here I will tell. So angles here you can take cos 0. Cos 0 is, so theta equal to 0, theta equal to 180 and theta 90 values. Okay, cos 0 you should know. Cos 0 value, cos 90 values and cos 180 values. Okay, cos 0 how much? 1. Cos 90 0. Cos 180 minus 1. Okay, so what is that one? What is the value of cos 0? 1. Cos 0 value is 1. Cos 90 value is 0. Okay, cos 180 value is minus 1. Okay, accordingly if you consider now, when we apply force on the object, so when we apply force on the object, so here you can take, I am taking like this. Sir, if you want to know this, sir, how I will get these values? So this is class 11 only, ma. Okay, so this is for class 11 only. Simultaneously it will be helpful for okay. So now you can observe. Here you can observe. I will teach a small technique. So anyway, we know this one. We know this one. So sin theta and cos theta. Okay, if you want to remember in easy way, so this is the technique. So 0, sin 0, 30, 45, 60 and 90. So sin 0, 0, sin 30, 1 by 2, sin 45, root 2, 1 by root 2, sin 60, root 3 by 2, sin 91. So reverse of sin only cos, we'll get cos 0, 1, cos 30, root 3 by 2, cos 45, 1 by root 2, cos 60, 1 by 2, cos 90, 0. Okay, so we are using these values, cos 0 value and cos 90 values and cos 180. 90 minus 90 plus 90 we are taking. 90 plus 90 in second quadrant, cos will become sin 90 we are getting. So minus 1 will come. So that's why cos 180 is minus 1. Cos 180 is minus 1. I hope it is very clear. Understood or not? So we are using these values. You are using these values. So keep in mind these values. Okay. So now you can observe. So you have to remember these values. Cos 0. So cos 0 1. Cos 90 0. Cos 180 minus 1. So when we apply force on the object moves in the same direction. Force and displacement are acting in the same direction. Then cos 0, theta is 0. Okay, then cos 0 value is 1. Okay, then W equal to Fs cos 0, then you will get 1. So Fs into 1, that is Fs. W equal to Fs. This is the maximum work done. When we apply force on the object moves in the same direction. So then we can say work done is maximum. Work done is maximum. Work done is maximum. So when work done is minimum, when we apply force on the object moves in the opposite direction. Force and displacement are acting in the opposite direction. So displacement in this direction, force will be in this direction. Okay, the angle between these two is 180 degrees. Okay, so W equal to Fs cos 180 degrees. So W equal to Fs minus 1, then W equal to minus Fs. Work done is minimum. Okay, understood or not? So work done is minimum. Minimum at this case. Work done is minimum. Coming to the work done, when work done is 0. When we apply force on the object, okay, so the object does not move. Okay, so observe carefully here. So listen carefully here. When we apply force on the object, so the force and displacement both are perpendicular to each other. So force is acting like this, displacement, the angle between force and displacement is 90 degrees. W equal to Fs cos theta. So cos 90 is 0. Fs cos 90, then W equal to, so cos 90 is 0. Work done is 0. So understood or not? One check here in this case. When the force and displacement both are perpendicular to each other, work done is 0. When we apply force and displacement perpendicular to each other, okay. I hope it is very clear. Just check once. Work, energy and power. Okay, so when we apply force on the object with some inclination, so with certain angle with the displacement, W equal to force, so F bar dot S bar, that is equal to W equal to Fs cos theta. Okay, so if force and displacement are acting in the same direction, theta equal to 0, then cos 0 is 1, W equal to Fs cos 0, Fs. So work done is maximum. When force and displacement are acting in the same direction, so then work done is 0. When the force and displacement are acting opposite to each other, work done is minimum. So when we apply force on the object and force and displacement are perpendicular to each other, the angle between force and displacement is 90 degrees, then work done is 0. Okay, so one is positive work, negative work and 0 work. So 3 types. One is positive work, next negative work, and coming to 0. Okay, so positive work when theta equal to 0, and negative work theta equal to 180 degrees, and 0 work theta is so 90 degrees. So very important. So when is work done is positive, theta equal to 0. When work done is negative, theta equal to 180 degrees. Between force and displacement, that angle is between force and displacement. These angles are between force and displacement. So when the force and displacement acting in the same direction, that time work done is positive, theta equal to 0. When force and displacement acting opposite direction, so work done is negative, theta equal to 180 degrees. And when force and displacement acting perpendicular to each other, so the angle between force and displacement is 90 degrees, then work done is 0. Work done is 0. I hope it is very clear. So work done is positive, negative, 0. Okay, so very, very important. So be very clear with that. So next one, so we'll discuss about energy. So what is energy? Energy is nothing but ability to do work or capacity to do work. Ability to do work or capacity to do work is called energy. Ability to do work or capacity to do work is called energy. So there are two types of energies we are discussing. There are many: heat energy, chemical energy, electrical energy, okay, mechanical energy, okay, thermal energy, so nuclear energy. There are so many. So in this topic now we are discussing about mechanical energy, that is about kinetic energy and potential energy. So okay, so let's start. Mechanical energy. So mechanical energy is a combination of kinetic energy plus potential energy. Kinetic energy plus potential energy. Kinetic energy. Okay, second one is potential energy. Potential energy. Okay, so what is kinetic energy and potential energy? So first of all, we'll discuss about kinetic energy. Energy possessed by the body by virtue of its motion. So kinetic energy. Kinetic energy. When the body is in motion, then the body has kinetic energy. So kinetic energy definition: energy possessed by the body by virtue of its motion is called kinetic energy. Energy possessed by the body by virtue of its motion is called kinetic energy. So the formula of kinetic energy: K equal to of mv square. K equal to of mv square. Understood or not? How we will get the formula? We will see. So we know that. So here is the object. So I am taking this the object. The object is at position A. Okay, object is placed at point A. So mass of the object. When we apply force on the object, the object moves. So the object moved to till B, and the same mass is not changing. So here you can observe same mass. So it reached to position B. So position B. So the displacement is yes. The displacement is yes. I am taking here. Okay. And acceleration is, so initial velocity and final velocity. Initial velocity of the body is u. Final velocity of the body is v. So we applied force on the object. Okay. So we know that when we apply force on the object moves, then work is done. So that is W equal to Fs. W equal to Fs. We know F equal to ma from Newton's second law. F equal to ma. So external force acting on the body is equal to mass of the body and acceleration due to gravity. Okay, sorry, acceleration of the body. So F equal to ma. So we know v square minus u square equal to 2s from equation of motion. V square minus u square equal to 2s. So from here s equal to v square minus u square by 2a. S equal to v square minus u square by 2a. So we can use this formula, substitute here. So whatever work is done on the body, that will become in the form of kinetic energy, because the body is okay now. So started moving. The body is in moving position. Okay. So when the body is in moving condition, it has kinetic energy. So we know F equal to ma and S equal to, what is the S formula? V square minus U square equal to 2a. V square minus U square equal to 2a. So here we can get cancel. A can be cancelled. So K equal to, so m into V square minus U square by 2. Yes or no? Now K equal to half into mv square minus half into mu square. if the body is starting from rest, if the body is starting from rest, so initial velocity is 0. Okay, it is very very important. Even though so if it is mentioned in the problem, the body is starting from rest. If the body is starting from rest means initial velocity is 0. Initial velocity is 0. Okay, so that's why the total term becomes 0. This entire terms become 0 because initial velocity is 0, right? Initial velocity is 0, that's this entire terms becomes 0. Then k equal to half mv square. Half mv square. The kinetic energy formula is, so k equal to half mv square. K equal to half mv square. Very very important. Once observe here. So energy possessed by the body by virtue of its motion is called kinetic energy. Energy possessed by the body by virtue of its motion is called kinetic energy. Understood or not? So object is at position A. So initial velocity u. So after applying force, the body is moved to position B. So it travels certain distance. Acceleration is there. So change in velocity is there. Automatically acceleration will be there. Okay. So we know work done formula W equal to Fs, K equal to. So whatever the work is done, that will become the form of energy, that K equal to. So F in the place of from Newton's second law, F equal to ma, and S equal to V square minus C square equal to As. S equal to V square minus C square by 2A. Substitute the value. A get cancelled. K equal to, so M into V square minus C square by 2. Okay, K equal to half mv square minus half mv square. So if the body is starting from rest, if the body is starting from rest, so initial velocity becomes 0, then kinetic energy formula is half mv square. Half mv square. Understood or not? I hope it is very clear. So I hope it is very clear. Understood or not? So is it clear? Understood? So try to understand. So if you have any doubts, let me know. Be very clear. So K equal to half mv square. K equal to half mv square. This is about kinetic energy. This is about kinetic energy. Coming to the potential energy. Coming to the potential energy. So we'll discuss potential energy. So energy possessed by the body. Energy potential energy. Potential energy is nothing but energy possessed by the body by virtue of its position. By virtue of its position is called potential energy. So here this is the object. So mass of the object is m. So it reaches to the position B. So initially A, final. So after certain distance it travels from here to here. That is height that I am considering h. That is S. Okay. So here acceleration, that is nothing but g, because the body is moving. So against the acceleration due to gravity, that acceleration is g. So we know work done. When we apply force on the object is moving. So that's why work done is force into displacement. So double equal to. So whatever the work is done on the body, that will become in the form of potential energy. So P equal to, so F equal to M into A into S, right? So M into, so A in the form of G, H in the form of S. So P equal to mgh. Okay. So potential energy equal to mgh. Okay. So work, energy and power in that. So double equal to force into displacement. P equal to mass into acceleration into displacement. Okay, so S equal to H, A equal to G. So point A to point B, same mass. Mass of the body is not changing. So that's why I'm taking same. So here M. Okay, so P equal to mgh. P equal to mgh. I hope it is very clear. Understood? So that is nothing but potential energy. So energy possessed by the body by virtue of its motion is called kinetic energy. Energy possessed by the body by virtue of its position is called potential energy. Energy possessed by the body by virtue of its motion. Motion is called kinetic energy. Energy possessed by the body by virtue of its position is called potential energy. Okay, so combinedly we can say mechanical energy. Mechanical energy. Understood or not? So next one. So I'll discuss about power. The rate of doing work is called power. The rate of doing work is called power. P equal to W by T. So we know W equal to mgh by T. Okay. So like this also according to the problems we can change the formulas. So according to that. So rate of doing work is called power. SI unit of power is what? SI unit of power is what? Okay. 1 horsepower equal to 746 watt. 1 horsepower equal to 746 watt. I hope it is very clear. So that is about power. Okay. So next one, collisions. Collision. So coming to the collisions. So collisions. Collisions are nothing but, so forces are coming with bodies are coming with a high velocity and colliding each other. Colliding each other. So different types of collisions are there. Okay, so your one dimensional collision, two dimensional collision. So initial velocities and final velocity, the bodies are lies on the same line. Then that collision is called one dimensional collision. So initial velocity and final velocity, the bodies lies on the plane. Okay, so with reference of x-axis and y-axis, with that at xy plane, then we can say two-dimensional collision, and three dimension with the z-axis also we are considering. Okay, so this is about one-dimensional collision and two-dimensional collision. So here elastic collision, inelastic collision coming. So like this it will be there. In elastic collision, both momentum and kinetic energy conserved. Means initial momentum, final momentum both are same. Initial kinetic energy and final kinetic energy both are equal. Both are equal. Okay, initial kinetic energy, final kinetic energy will be equal. So kinetic energy also, initial kinetic energy and final kinetic energy will be same. Okay, so that is about conserved is nothing but, so both are same. And the next one, inelastic collision. So momentum will be conserved, but kinetic energy does not conserve. Okay, kinetic energy not conserved. So coming to the law of conservation of momentum. So initial momentum. So that is m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. After collision, so momentum before collision equal to momentum after collision. Even for a law of conservation of kinetic energy also same. So kinetic energy before collision equal to kinetic energy after collision. So half m1 u1 square plus half m2 u2 square equal to half m1 v1 square plus half m2 v2 square. I hope it is very clear. Okay, so I hope it is very clear. So thank you so much for joining and attending and listening my class. This is your Shiva sir from Student the Brand. So I will come with a different topic with a different okay na. So next. So thank you so much for joining and attending and listening my class. This is your Shiva sir. If you like the content, if you like the channel, do like, share and subscribe to Student the Brand.